Hello, my name is Antonio, and I'm presenting a demo for our scientific paper that has been submitted to the special issue on large language models and data quality for knowledge graph, the Information Processing and Management Journal. The purpose of this demo is to show how the combination of knowledge graph, specifically the Wikipedia knowledge graph, and large language models, LLMs, can bring improved explainability, better detection of hallucinations, and access to up-to-date, reliable knowledge for a wide variety of tasks. The LLM we'll be using in this demo is Llama 3.1 with 70 billion of parameters, our powerful model developed by Meta, which has shown an impressive performance on a variety of benchmarks while running from an intermediate hardware, making it well suited for our project. Before diving into a technical demo, let's briefly introduce the Wikipedia, the knowledge graph we'll be supporting this project. The Wikipedia is a community effort to extract structured information from Wikipedia and make this information available on the web. It serves as a cross-domain knowledge graph, providing access to a wealth of data that can be utilized for various applications. We will take advantage of its SparkQL clients and its lookup service. In this demo, we will create a React agent using LangChain for Python. Its main components are the large language model and the tools which the agent have access to that can interact with the environment. In first place, we are going to look to the two tools which the agent have access to, which are Wikipedia Entity Search Tool, which allows the agent to search for the entities in Wikipedia for a given query, in which we basically call lookup Wikipedia API and then apply some filtering using an LLM to check what of the entities we have retrieved from Wikipedia are really relevant to this question. On the other hand, we have another tool, which is called the Wikipedia Entity Info Tool, in which we will use SparkQL to extract all the properties associated to a given URI that identifies an entity. Next, we are going to take a look at the agent itself, where we first instantiate the wrapper for our server, instantiate both of the tools, then create a prompt template based on prompt templates found in Hugging Face, where we specify the plan specify to the model how to use the tool in a proper way in order to make a good plan to find the answer to the main question. We also provide the structure for the output parser for find when to call the tools and how to proceed, and also provide several examples to illustrate the few-shot learning that LLM shows nowadays. Then we instantiate the agent executor with a large number of iterations, but not too large because the context window of Llama 3.1 is not that big. And then we just provide the main question and some additional context that can be provided that won't be passed for the filtering of the Wikipedia tools. Finally, we will get the final answer, and we will also get all the properties that have been obtained after filtering by calling Wikipedia info tool. With this, we will create an MXT graph that will plot as follows. Finally, we can observe the Wikipedia subgraph which back up the agent's answer. You can see that here Canada has the population that the agent has answered, France and also Bolivia. And also we have the capital of all of the countries, and the continent is deduced from the time zone of Bolivia and France. But in Canada, I wasn't able to obtain any hint of the continent. Uh, Nevertheless,